In this video, we will see that how can we take the derivatives of trigonometric functions using product or quotient rule of differentiation. So we all are familiar with the derivatives or with the trigonometric rules of differentiation. So here are the formulas for your information. So when any question is given to you, the first thing is to analyze the function. So here you can see that the two functions are multiplying with each other. So the first thing comes in our mind is to apply the product rule of differentiation. And according to product rule, if the two functions, namely f and g, are multiplying with each other, their derivative will be given as, write the first function, take the derivative of second function, then put the plus sign, write the second function as it is, and take the derivative of the first function. In your case, you can see that the first function is your f and the second function is g. Now what you have to do, that you have to put all the things according to the formula. Means in place of f, you have to write x square, and in place of g, you have to put the sin x. Wherever there is a prime, you have to put the prime, and where there is no prime, don't put the prime. Prime means take the derivative. Anyway, the first function f, that is x square. G prime, it means you write the sin x with the prime outside. Then put the plus sign. G, that is your sin x, and then f prime, it means write the x square with prime. Now the second thing you have to do, take the derivative of the functions where prime is written. So write x square as it is, and we know that the derivative of sin x is cosine x. So write here cosine x. Plus write the sin x as it is because there is no prime over here, and the derivative of x square using the power rule is 2x. Here you can see that there are 2x, means x, and over here you have 2 and x. So we can say that x is common among the two terms. So write the common factor outside. Now whatever left, write down inside. So what is left here? Here we have 1x and cosine x left. So you write x and cosine x. Then this plus sign, put it here. So plus. Then over here sin x and 2 is left because this x is already outside. So write down 2 sin x. So this is the complete answer. Now we can see over here that the two functions are dividing with each other. So whenever the two functions divide each other, we use the quotient rule of differentiation. Now in quotient rule, if two functions are dividing, we will write gf prime minus fg prime over g square, but all the time the numerator will be named as f and the denominator name it as g. Then apply this formula. Do not change the sequence of them because there is a negative sign. It would affect your answer. So have a look here. What is written? G. So write down 1 minus cosine x is your g. F prime, that means the numerator sin x with the prime. Minus put as it is. Then f, that means the sin x, and g prime, which means 1 minus cosine x with prime. Don't forget to put the prime. Now g square, which means 1 minus cosine x whole square. Now 1 minus cosine x stay as it is. The derivative of sin x is cos x minus sin x, write down as it is. The derivative of 1 is 0. Then you put here the negative, and derivative of cos s is negative sin x. So negative negative, positive sin x. Now open the bracket. 1 minus cos x whole square. Open the bracket. Cos x times 1, which means that anything multiplied by 1 gives you the same thing. So write cosine x minus cosine x times cosine x, it will give you cos square x. Some students, when they multiply cos x with cos x or sin x with sin x, they write cos x square. Yani they put the square here, which is absolutely wrong. You must write in the proper way, that is cos square x, or it can also be written as cos x whole square. But the right and the correct way is cos square x. Here, yani we are already in grade 12, so we must write cos square x rather than cos x whole square. Okay, now negative sin x times sin x, it will give us negative sin square x over 1 minus cos x whole square. Now, we have studied in grade 11 trigonometry, there is a formula of identity that sin square x plus cos square x equals to 1. This is our trigonometric identity. So I can clearly see that here I have negative sin square x, negative cosine square x. So from here, if I take only negative common, so inside signs will be changed. So I will get cos square x plus sin square x. Remember, if you have any problem in taking the common, if you are getting the problem in taking the common factors, remember that after taking the common factor, if you multiply the functions again with the common factor, you must go back to your previous state. If it is so, then it means your common factor is correct. If I open minus cosine square x, it gives me minus cosine square x, minus plus it will be minus and then sine square x, which means I get back my previous position. So my common factor negative is workable. Now 1 minus cos x whole square. Okay, now sine square x plus cosine square x, we just said that it is equals to 1 over it is 1 minus cos x whole square. Remember one more thing which is very important and we already have studied in our algebra, that if I have two factors dividing with each other with the exact opposite sign. So for example, if I have a minus b in the numerator and in the denominator the same terms but exactly opposite signs, which means the plus a here plus a and the denominator it's negative a. Similarly, the second term is negative b and the denominator is positive b. If it is so, you can either take the common of the upper one, and if you take the common negative, all the signs will be changed. So you will get negative a positive b, which is exactly same as the b minus a. You can cut them and then after cancelling you will get negative 1. But since right now we are studying the calculus and if the concept is clear, when we cut in this way, just do not show the step, write negative 1 directly. So here cos x minus 1 on the top and you can see 1 minus cos x, exactly same terms but opposite signs are written. You can cancel them and put a negative sign, but to show you cos x minus 1 over here, since I have two squares, so I will write 1 minus cos x and 1 minus cos x. You can do directly also, just I am showing you for those who have the difficulty in algebra. Now cos x minus 1, 1 minus cosine x, when it cancel out, we get negative 1 answer from here, keeping this concept in the mind, which I wrote above. And in the denominator now 1 minus cos x left. So you have to apply the quotient rule or product rule, but finally you have to simplify and give the final answer. So hope you understood these questions. Now let's practice more questions. First, we will solve the question over here, which is written on the gray. Y equals to cosine x minus 5 over x cube. The first thing is that we must analyze that which rule we are going to apply. I have a negative sign here. Whenever positive or negative sign between the two terms, it means take the derivative of the first term separately and the second term separately, which means here we are applying difference rule of differentiation. So the derivative, write down here, y prime equals to derivative of cos x, negative sin x. Now here 5 over x cube I am writing here just to show you that I cannot take the derivative of 5 over x cube directly, because this x cube is in the denominator. I should change the position of this thing and I will get 5x to the power negative 3. Now I am ready to take the derivative. So negative 3 times 5 I will get negative 3 times 5 I will get negative 15. X power negative 3 negative 1 gives me negative 4 power. Now either stop it over here, but I would not prefer it because the power is negative. So bring it again down to make it positive. So over here also we can apply the quotient rule, and here you can see that this is our f and the denominator will name as g. The quotient rule is gf prime minus fg prime over g square if the two functions are written in the form of f over g. So let's take it directly. So g is 5 plus cosec x. F prime means 5 minus sin x with the prime, minus f, that means 5 minus sin x, and then g prime is 5 plus cosec x with prime, divided by g square, which means 5 plus cosec x with whole square. Now 5 plus cosec x we will write as it is. Derivative of 5 is 0 and negative derivative of sin x is cos x, minus 5 minus sin x as it is, and derivative of 5 again is 0 and derivative of cosec x is negative cosec x cot x over 5 plus cosec x whole square. Now open the bracket. 5 times negative cos x gives us negative 5 cos x, plus cosec x times cos x give us negative cos x cosec x. Now this is negative, so write the negative as it is, open the bracket, or do it directly. Cosec x cot x times 5 give us negative 5 cosec x cot x. Negative cosec x cot x times sin x, negative sin x, it gives us positive cosec x cot x sin x whole upon 5 plus cosec x whole square. Now it is negative 5 cos x as it is, negative cos x cosec x also as it is. Negative negative gives us positive 5 cosec x cot x as it is, plus now here we have cosec x cot x sin x. Now I know that cosec x is 1 over sin x and this is the sin x. So if I write here in place of cosec x 1, if I write here 1 over sin x, this cot x if I write as it is, and this sin x I write as it is. Why I am doing this? That doing this way, this and this will cancel. But negative and positive gives me negative. So this has to be a negative sign. Over 5 plus cosec x whole square. I am not writing because of the shortage of the place. But let me write for you on one side. Like here I am writing 5 plus cosec x whole square. Now let's see here. I have negative 5x. And here cosec is 1 over cos, and here also 1 over sine. I can't do anything, and cosec x, cosec x, cos x, cosec x, and that's it. So I don't have any common either. So whatever is left is my final answer. So I don't think that here negative 5 cos x, cosec x, here cosec x, cot x, it won't give me anything, any chance to mix them up. So that is whatever is left is my final answer. Now let's see y equals to cosec x cot x. So here we will apply the product rule, which means fg prime plus g f prime. So y equals to cosec x as it is. The derivative of cot x is negative cosec square x plus cot x as it is. Derivative of cosec x is negative cosec x cot x. Now here we have cosec x and cot x common. Cosec x is common. So I can take the cosec x common. So what is left inside? It is negative cosec square x and negative cot cube x. Negative cot cube x. That is my final answer. Now here in the second question, you can see again I have f and here is my g. So I will use my product rule. I will write here sec x as it is. Derivative of g is 2x plus g as it is, and derivative of sec x is sec x tan x. I have only one common, that is sec x, so I will take the sec x common. What is left I will write inside, that is 2x plus x square plus 1 and then 10x. You will, if you want, you can open the bracket with the 10x, otherwise you can leave it over here. So you will get 2x plus 10x and x square plus 10x. Remember, whenever we have any trigonometric functions, you write them first sign, then number, then variable, then trigonometric function, and in the end the angle. So this sequence is the best sequence to show our trigonometric function after the multiplication or after the simplification. So here is our again quotient rule. Here we will apply f and g. So we have the formula gf prime minus fg prime over g square. So how can we write? Let's collect the data for you here. Okay, so you write the g, that means 5 sine x plus 1. F prime, so I just want to show you here the data. F prime, derivative of sine x is cosine x. And g prime, so derivative of 5 sine x is 5 cosine x. And 1 is 0. So I will write directly here. So we have g and then f prime, I will write directly cos x minus gf prime minus f, that is our sine x, and g prime, so it is 5 cos x. Over g square, it means 5 sine x plus 1 whole square. Now open the bracket by multiplying the first bracket with the cos x. So we will get 5 sine x cos x plus cos x times 1 gives us cos x only, minus sin x times 5 cos x sin x gives us 5 sin x cos x. Here I forgot to put a x. Now over 5 sin x plus 1 whole square. Now this 5 sin x is the negative and here it is positive. They will be cancelled out and your final answer will be cos x over 5 sin x plus 1 whole square. Okay, so let's see how can we solve this question. So here, as you know, that this is the quotient rule. Here we are going to apply rule gf prime minus fg prime over g square. Our f is secant x and g will be here 10x plus 1. Now, if we take the derivative of secant x, it will be secant x tangent x, and the derivative of 10x plus 1 will be sec square x. I wrote it here directly so that we can apply and we will put these terms in the formula directly. So we will write here y prime equals to, the numerator is f and the denominator is g. So it's written g, so you will write 10x plus 1. F prime, so here is the f prime, that is secant x tangent x, minus f, that is my f is sec x, and g prime, that is sec square x, over g square, that is 1 plus tangent x whole square. Now open the bracket better. So sec x 10x times sec x will give me the sec x as a common, and I feel that rather than opening the bracket first, why don't I take the common first and then I open the bracket, so it would be easier for me. So sec x is the common, and after sec x taking the common, what is left? 10x plus 1 times 10x and minus sec square x. Now open the bracket with the 10x pattern. If you first open the bracket and then take the common, also up to you. So sec x is the common thing. Now 10x times 10x gives me 10 square x plus 10x times 1 gives me 10x minus sec square x divided by 1 plus 10x whole square. Now let's see, can I apply the identity or not? So I know that 1 plus 10 square x, it is equals to sec square x. Okay, so 1 plus 10 square x will give me sec square x. And if I put here sec square x minus 10 square x, it is equals to 1. So I can take negative common for this one. So if I take negative common only for this one, means write the 10 sec x as it is outside. Inside write the 10x as it is, means this one, this plus 10x I wrote as it is. Now in the 10 square x and negative sec square x, I want to take negative common. If I write the negative common, the sign would be changed. That means secant square, right now it is with negative. So inside the bracket it will gives me positive secant square x. 10 square x, here it is positive, so I would get negative 10 square x. Why I am doing all these things and down is 1 plus 10x whole square. Why I am doing all this? Because in place of sec square x 10 square x, I want to write 1. So I will get sec x then 10x minus 1 divided by 1 plus 10x whole square. I cannot cancel anything. The reason is that in the denominator there is a plus sign. So try to understand this question. The place is very messy, but if you do not get any step, please rewind the video and watch again. You will understand, of course. The basic thing is that in order to solve the trigonometric functions, it is very important that you must remember the previous concepts which we already have studied in grade 11, like the concepts of identities, or how the sec x can be equals to, it is the reciprocal of cos x, or cosec x is the reciprocal of sin x, and so on. So I hope that the basic concept, when do we apply the product or quotient rule along with the trigonometric rules, is clear to you. So see you in the next video. If you like the video, please send the comments or just press the hit button like. Thank you.